The last thing I want to talk about it is the uh, Bode plot, and they say what are the mm, what are them, why we use them. So I just go ahead and give a very short introduction about them. I will not go through the detail. Before I say what's the Bode plot, one thing that I want to mention that we can, when we are dealing with uh, um, the filter and the when we we have the transfer function of the filter, we usually can write it as it is, or we can write it in a decibel format. So if we want to write the transfer function of the filter in the decibel format, it's going to be the HF, the magnitude of that in decibel format would be equal to 20 to log 10 of um, the, the magnitude of the HF in the so we can write it, so we can use this equation to convert the, the magnitude from the the normal number that we have to the decibel number. And if we do that, all these values is going to be negative. So the maximum value of that transfer function becomes 0. And then everything else is going to become negative. Know that if we use this to plot the filters, what we are going to get is going to be the Bode plot. And I'm going to show you how it's going to happen. So I'm going to draw it for the um, first I'm going to draw it for the low pass filter, and I'm going to draw it for the high pass filter, the first order low pass filter and first order low pass filter, to see how it's going to look like. The most benefit it has is just much easier to follow what's happening when you plot it rather than plot it in normal scale. Remember that it's very common that when you're working with in the filter in the frequency domain, it's very common that plot everything in the logarithmic scales. It usually make it much easier to work with. So if I want to draw it for the low pass filter, if I draw the frequency like that, and then so it's gonna be the frequency. So everything is going to be negative. So I'm going to put the frequency up here. So it's going to be the frequency, and it's usually is in the logarithmic scale. And then I draw so it's going to be the magnitude of HF, the magnitude of the filter in decibel. So this one is in log scale. So we draw it in the log scale. And if we have it the same thing for so it's going to be the frequency again in the logarithmic scale. And then just magnitude of the angle. So it's going to be the angle of that. I would write it like that. So the angle of that HF. So both of them start from 0. Or let me. Okay. So if I go ahead and draw now this for the low pass, so this is for the first order low pass filter. What's it gonna be is usually it's gonna look like something like that. So it goes ahead close to 0, and then we'll have something like this, and then it goes down. So this is the lower frequency, which is the it lets everything pass through, and this is the higher frequency that, because the let me write it here, so it's going to be the low pass filter. So first order low pass filter. So it's a first order low pass filter. So when you draw it in this scale, you can see that up to this point, which is 0, it means this is a part that is let to pass through, and when it goes to the very negative number, it means this is the part that is actually reject them and doesn't let them pass through. Usually they simply, to plot them, usually it plot them with 2 lines. So they may go ahead and say, okay, there is one line going straight ahead up to here, and then another line goes from there to there. So it's very common to draw them like that. So instead of having this curve, there's just one horizontal line and one vertical line, and that point here is the cutoff frequency. So basically they said what is less than cutoff frequency is not going to change much. What is going to be larger than cutoff frequency should be rejected. The same for the angle. If it starts again from the 0, so it will goes, I try to draw it, goes close to 0, so it's not going to change much when it is close to the 0, and then it goes down, and then it goes like that. So down here eventually we get close to the negative 90. And also this one can be estimated with again the horizontal line. So it goes, for example, can be the horizontal line here, then the horizontal line here, here, and then there's a, for example, something like that that goes from there to there, something like that, and then it's going to be the FB. So sorry, the FB. The FB is going to be something sitting right in here, in the middle, where it's going to be actually 45 degrees. So it's going to be the FB. So this is a low pass filter. So usually it's just easier to look at it to see to what's happening. There's the same that is happened. So usually they use this straight line rather than this curve line. So it says, okay, this a straight line go to the FB, so nothing changed. Then when it gets to the FB, suddenly dramatically it's going, the magnitude of that is gonna drop. So this is a we can see that is the Bode plot for the low pass filter. The same I can do that for the high pass filter as well. So I just try to draw. So for the high pass filter, again we have the frequency like that. So the frequency in the logarithmic scale. And then we have the magnitude of the filter in decibel format, which starts from 0 and goes down. So it's the magnitude of the filter in decibel. And because it is in decibel, so it's going to be, the whole thing is going to be negative. And also the same here is going to be the, again, the frequency in the log scale. and the angle which is starting from 0 and goes negative value. Sorry, the angle goes from no. So the angle is not that me. The angle is actually going to be positive. So I'm gonna so this is going to be again the F in larger scale, and then you have this angle which is going to be in angle of HF. So if I again go ahead and draw that for the if it is 0 here, so it goes like this. So it goes like that. And then usually, as I said, they would just replace them with two straight lines. So it says, okay, it goes up to here, and then when it's reached there, it goes straight forward, and then they call this part as the cutoff frequency. So when it's in the, as I said, it's the first order, the first order high pass filter. So it's supposed to let the higher frequency pass through without any change, and then reject the signal with lower frequency, which it does here. And if you draw the same for the angle, what we're going to get is going to be something again, something like that. So it goes from here up to here, and then goes back towards 0. So it's going to be, or maybe it's not going to 0, but so it's going from here, here, it's going like that. So it's 90 degrees here, and it's 0. And then also the same here. They usually might let me draw that different way. So they usually try it to sort of, let me draw that. So it's going from here, going all the way here. And then they try to also estimate it with a straight line. So it goes, the straight line goes here, it's going to be 90 degrees, then up to here is going to be like that. And then you are going to have a line connect these two together. So okay, have the line goes like this, and then here that when it's actually 45 degrees is going to be the cutoff frequency. So this is how the Bode plot works. So you plot the filter, the magnitude of transfer function of the filter in the vertical axis in as a decibel, and then the horizontal axis as a logarithm. Another way of, it's not the Bode plot, but it's another way of plotting. Also, you know that is that just use in logarithm. So instead of putting in decibel, just use the magnitude, just the normal magnitude, but use the logarithm scale for the magnitude and the frequency for both of them, and plot them both of them in log-log plot.